Welcome back, everyone. So I have the great pleasure of talking to you about network load balancing. One of my favourite subjects. So, as I mentioned yesterday in terms of introduction, I came to Baker Cut last year. Before that, I was at an OEM. And interestingly enough, for my sort of last 3 years of tenure there, I got involved in a lot of load balancing implementations for peripherals. So I sort of live and breathed and assisted in implementing this stuff in real life customer situations. So yes, to say it is one of my sort of favourite topics. Sorry.
Tell me it doesn't click.
It's not clicking.
It's weird.
What's that? Right. Thanks, Matt. So the goal of this session is not to turn you into network load balancing gurus or experts, but it's to give you the core concepts that equips you that, when you or the channel are talking to customers that have network load balancers, so you can talk in the same lingo or the same language in terms of what the requirements would be for a paper cut installation behind a network load balancer. So in terms of agenda for this session, it's split sort of in three really. There's the presentation piece that you'd expect. Then I'm going to delve on to 3 network load balancers and take you through the configuration of those 3 different variants of network load balancer. And then at the end there is a lab where everybody has got access to an environment where you're going to be able to get some hands-on and configure a network load balancer to work with paper cut. Right, so the first place to start is really just to make sure everybody is comfortable with what network load balancing is. So I'm going to throw that open to the room and see if I get any responses. If I say network load balancing to you, what does that actually mean?
Don't all jump at once.
Yep. Anybody? Somebody?
Well, I guess it's quite self-explanatory.
Humour me, Alex.
Distributing some traffic around a network sort of thing, evenly, maybe about halfway. Didn't know what I was going to do.
Okay, so load balancing is just, as Ross said, it is just that. It's the process of distributing network traffic across multiple servers. So it ensures that no single server ends up with too much demand on it. That's the core concept behind network load balancing. Traditionally, where this came to pass, and I'll come on to that in a second on the next slide when we talk about the history of network load balancing, but predominantly it's been used with high volume websites. So it allows where you've got a huge number of client connections to machines that are connecting to a resource. You're able to distribute that load of those requests. Could run into hundreds of thousands, if not a million, concurrent connections across a number of servers that are transparent to that client machine. It obviously, by the nature of it, then ensures that high availability and reliability by sending requests to servers within that pool, as it is called, that are available online, and that is done through something called health checking that we'll come on to later. And as Damien talked to yesterday in the Fully Brewed presentation, it does allow for this flexing of the infrastructure. So you can add additional servers or you can remove servers depending on what load is going through. So obviously the other core thing with load balancing is those network load balancers give you that sort of management information in terms of what that load is, so you can then scale accordingly by either adding additional resources or removing them to obviously reduce cost. Any questions so far? Okay, so a bit about history. So load balancing, it goes back to the sort of the 1990s. where what was used at the time there was traditional sort of hardware appliances that would provide that load balancing capability. Organisations obviously wanted to improve accessibility of the applications that are being serviced by those app servers or web servers behind the network load balancer. Interestingly, as early as back in 1993, Microsoft did actually see there was going to be this future requirement for load balancing capability, and they acquired a piece of software from Balance Research that later became the Windows NT load balancing service. So this goes back quite a way. The term application delivery controller, so this is the sort of where load balancers have evolved into. So it brings not only load balancing capability, but also additional capabilities, such as being able to handle secure websites, being potentially an intrusion point into an organisation. That's what the ADC is. So if I use the term ADC, that's what I'm referring to. ADCs fall into typically three categories. There is the appliance type hardware that you literally roll into a data center or into a server cabinet, into a rack or a server rack. There is then the virtual appliances. So typically the virtual appliances where the likes, and we'll come on to the players in the arena in a minute, have taken the software that they're running on their appliances and put that into a package where it's a virtual type server that can then be deployed either on-premise or now with the advent of the cloud. What we're starting to obviously see or have in recent years is that the likes of F5 and Kemp are providing cloud-based load balancing capability as clients move their infrastructure into the cloud. And then lastly, the third type is the software, true software load balancer. So you can find this on Linux type platforms where you can then use a fairly efficient type of load balancer at a software level, but it might not have the same level of capability, advanced capabilities, as the likes of the traditional hardware appliance. Okay, so if we look at hardware versus software, what are the differences between the two? So as you can see on the screen here, some images of some of the big players, F5, Netscaler. Those hardware appliances are tuned in terms of the hardware to provide the type of throughput that you need for network load balancing. So the actual circuitry inside those units has been refined over the years to really give you that high speed type connection. So there's obviously that advantage if you're using a traditional hardware appliance, is you've got the circuitry and the NIC interfaces in those devices that provide you with the high speed capability. The other thing that hardware provides you with is typically these things are sold with some form of service contract. So if you are looking for, for customers looking for 24/7 type support within their environment, they've got that on the hardware. These things can obviously be made highly available as well, so you can have clusters of application delivery controllers within an organisation. They also, as I said, they bring some advanced features. One of those might be something such as global solutions load balancing, for example. So the way that we're working with paper-cut, we're using a more traditional, simple method, but the likes of F5 and Netscaler provide global solutions load balancing. And what global solutions load balancing does is it allows you a single entry point that you can then balance that traffic to multiple pools of servers based on a geographical location. So, for example, if you have a worldwide organisation, you may well have a GSLB load balancing capability. What you have is you have a single entry point that might be, in the case of printing, print.gslb.company.com. Okay, that's the entry point. So if you're rolling out devices worldwide and workstations, everything points to print.gslb.domain.com. So that means simple configuration of devices. They can all be configured the same. Based on the source initiating IP address of that MFD, if it's in the Americas, any inbound requests will then get automatically routed to a pool of servers that are within an Americas data center. Similarly, if they're in Europe, any devices initiating from an IP address that's a European IP address will get routed to a set of servers that are load balanced within the European data center, same in Asia Pac. So that's what global solutions load balancing is. Software-wise, software configuration, there's really a couple of downsides, I guess, with this. Is it's not necessarily as easy to configure. You are into editing text files and that sort of thing. There's not necessarily the rich GUI interfaces that you'd expect on some of the hardware appliances. Plus, as you're editing a configuration type file, the support on that is potentially likely to be limited, i.e. you've developed it, you support it type mentality. Any questions on hardware versus software?
Oh, last one. So sorry, we go back to the diagram where you had the data going through the load balancer and then onto the service behind it. So I guess this one here. So it's not necessarily always the logical flow of data then, so you're talking about the
GSLB.
GSLB.
Yeah, so this diagram represents what I'll come on to in a moment, which is where you've got a virtual service. So everything is coming through a virtual service IP address.
Mm-hmm.
And then behind that you have the pool of servers. So we've got 3 servers in support.
Mm-hmm.
The way that the GSLB works is you would point to a single entry point, which is one pool, and then beneath that you then have a pool for each region with pools of servers beneath there.
Yep.
And the logic sits at this level, this first level in that scenario, where it's looking at where in the simple scenario, the source initiating IP address of the request. So it then knows that, right, that's an IP address that's in the Americas region. Forward that to this name here, which might be print-us .gslb.company.com.
So if we had our network load balancer in, say, the Melbourne office, and someone was printing from Portland, it's not to say that all drops have to go from Portland to Melbourne to come back again. You can still shortcut it so that all the communication stays locally.
Yes, that's exactly what it's for. Yeah, sorry, yeah, that's a good point, Damien. Yeah, so it's to keep the traffic within that local region.
Cool, thank you.
That's the idea behind it.
So,
Any other questions?
yeah, so when we were looking at it yesterday and Papercut was coming up with the client being the load balancer, would that not be an issue if you were using the client as well and getting the traffic back from an app server to the client? Because is it going to be able to see the client?
Yeah, it's whether in our test environment here, I don't think it's not configured correctly with the IPP, but you have the ability to pass through the initiating IP or hostname through to the endpoint within the configuration of the virtual service.
So it can then go that way and then come back around the outside to get
And the other thing, which I'll come on to in a moment, is there's another mechanism where, rather than coming back by the load balancer, the end service here will actually talk back direct to the workstations.
Any setup that creates that problem we saw yesterday, where the actual client isn't right, is effectively the same problem as that NAS narrative.
Yeah.
And I'll offer it again if it wants 5 or 10 minutes to run through what Papercut doesn't work with NAS. I'm happy to take them through that in more detail. But yeah, if you can't reliably see that client on that job pending release tab, it's going to be really hard for us to trigger a pop-up at their desktop to ask them to choose a shared account as an example, because we're going to try and send that back to, in this case, the address of the network load balancer, and there's no client installed on that network load balancer.
Right, okay. So what I've got now is a few slides that just talk through some of the key players that I've seen and that we've seen here. If there are other ones, it'd be great to open the room up to discussion around those as well. Okay. So, and Alex mentioned this to me yesterday in terms of Microsoft load balancing. Why would we not use that? So my knowledge of this is that whilst it is something that's in operating system, so it is a feature that can be enabled on a modern Windows operating system to provide you with network load balancing. It is great for simple network load balancing, so intranets or SharePoint sites. But it does have some limitations in terms of the sort of what I would term the system's health monitoring of those servers that you're actually balancing to. The other thing from a paper cut and printing point of view is Microsoft are quite clear when you start to research on sort of their TechNet articles that they do not support using their network load balancing for printing on their Windows print servers. So that's one to be aware of. Nginx, so this is a software load balancer that's typically available on Linux. I don't know how much people know about this particular brand and where it's come from. Okay, so they sort of started life in the early 2000s, and they started really as providing web servers. So that's where their core business started. They then evolved into providing that load balancing capability across their core product set, which would have been load servers. So, you know, they are used today by the likes of Netflix and Starbucks, for example. Just a few names as to who's using this technology, because there's an open source version of it, plus there is then a paid version of the software. They make some quite dramatic claims. You know, estimating you could save sort of that sort of figure compared to using a hardware load balancer. So, you know, some clients might go down this route, especially if they're of a Linux, you know, background, and that's what they're using for their servers. Because of that, it's supposedly highly scalable, low footprint, and it does support more than, say, the Microsoft network load balancer from a load balancing algorithm that we'll come on to in a second, but it's still not as, you know, capable as other products like HA Proxy, for example, which is used in load balancer.org's network load balancer. F5. Okay, so the F5 big IP, which I think, you know, I know a number of people in this room are aware of that from customers that have got it that are trying to use paper cut with it. This is really one of the Rolls-Royce type application delivery controller solutions out there in the marketplace. They provide obviously the traditional hardware appliances that you'd roll into your data center physically. They have now moved that technology into a virtual appliance that is available to be used on-premise or up in cloud platforms. You can install F5 instances to use for load balancing up in the cloud for your servers. They are typically fairly expensive. You're looking at that sort of price range upwards. The GUI on it for the type of configuration that we'd need to do for paper cut is very easy to use. And you're going to see that later on when it gets to the practical sessions. It's actually an F5 that you're going to configure. So whilst the interface has lots of features and capabilities, when it comes to sort of the more basic virtual service load balancing that we're going to be doing to get paper cut up and running, it is very simple to configure. I put on there that it can be complex to configure when you start to get into using some of their own scripting capabilities like iRules, for example, on there, where you can really go to town on the system health monitoring, which if a customer's got the skill set, they could use that with, say, the paper cut health monitor endpoints to actually be looking at whether a secondary server is online or not from a paper cut perspective. NetScaler, so similar in the marketplace when it comes to application delivery controllers or load balancers to F5. They, again, have hardware and virtual appliances. What is quite interesting is on their hardware appliance, they have a virtual, a hypervisor type level where you can actually then run additional virtual instances on the hardware that they provide. So, you know, it gives you that dual capability. They're recognised as having a really easy GUI, even more so than the F5 when it comes to configuring. Again, the starting point is relatively expensive, but they do have, you know, more advanced features which, you know, the likes of Citrix and F5, they've obviously got huge long courses on each of those purely around their network load balancing. So they are really capable devices. So that's why customers might favour those if they put budget over some software or the virtual type appliances. Ken. So again, I know at least one person in this room has used Ken and configured them. They are more affordable. Again, they offer a hardware appliance that can be rolled into a data center and a virtual appliance. As I mentioned yesterday, we were using the Kemp free Loadmaster in the fully brewed environment we were talking to yesterday. So that is completely free, that version of Kemp Loadmaster. It does have a couple of limitations, but yeah, it's something you can use in a lab. Again, it's relatively easy to configure. What they also have in addition is they have a software version of their Loadmaster capability that can be loaded onto a physical server. So if you go out and buy a Dell or an IBM type server, you can install onto bare metal and use that server to provide load balancing capability. Cons, again, it's not in the same marketplace. The price sort of dictates that, or the entry price dictates that. It's in different areas of the market than the likes of the F5 and the Citrix NetScalers. They've got limited reporting and statistics when it comes to that sort of management information I mentioned earlier, to be able to monitor what load is going through and flexing that infrastructure. And some of the comments I've read in terms of reviews around the Kemp is that the interface is quite clunky to use, so the usability isn't great, but it's down to a system admin at the end of the day, isn't it? Any questions on what I've gone through here in terms of the players in the marketplace?
One on the engine.
Yeah.
Is that just Linux, or does it work with other, or does it matter what the operating systems of the servers are that are talking to it?
The load balancing software runs on Linux. The open source version of it runs on a Linux platform. Obviously, you are load balancing traffic, so you can quite happily put Windows print servers behind that. And use that as a low-cost way to. But as I said at the start, we're not looking to make you load balancer experts. This is about what the customer might already have infrastructure-wise in their infrastructure. Yeah, but yeah, to answer the question, Windows Service Plan is not going to be an issue. Okay, so we've covered the history, players in the marketplace. Let's get into the meat of what we really want to actually learn, which is how do these things actually work, and what are the core concepts that are going to allow for the conversations to happen with a customer's sysadmin or network person that's responsible for looking after their load balancers. Right, this term, virtual service or virtual IP, is something you're going to hear talked about when you get into network load balancer conversations. So this is really a core component of concept when it comes to network load balancing. The virtual service effectively advertises an IP address that the client machines are going to make a connection to have that traffic balanced. So that's its core purpose. It's going to proxy a client network connection. It then has the ability to perform some additional capabilities, such as performing security or acceleration, if you're using, say, a physical virtual appliance, and it's going to load balance that traffic and also take account of the statistics in terms of what's gone through it and where it's been balanced to, etc. And then it's obviously going to forward those client requests to that pool I talked to earlier of servers that sits behind that single virtual service address. It's at this level as well, depending on the load balancer technology that you're using, that you actually can define what's termed as persistence settings. So that is the stickiness, if you like, to a server within that pool. So you can adjust that on the virtual service level. If you're load balancing a website, we step back to balancing websites for a second, and that's maybe an e-commerce or an online website where you have a checkout and a basket. You are not going to want to set your persistency settings on your virtual service to have no persistency, because every time that web page refreshes after you've added something to the basket, there is the danger that you could be bounced to another server that knows nothing about what you put in your shopping cart or your shopping basket on that website. So this is where the persistency settings come in, that you can adjust that to make sure that I'm always going to get back. If I get bounced to server 2 to begin with, all my future requests for a period of time will go to server 2 that's going to handle my requests.
Is that on caching? Is that on timing?
You can set a timeout on there on persistency. So that's one way of doing it. There is also the ability to use cookies as well. Yeah. Any other questions? Virtual service? Okay, load balancing algorithms. So the next step, once we've got our virtual service defined with the IP address that we're going to accept requests from, we need to define how we're going to balance across that back-end pool of servers that are running our application or our website. So there's various different load balancing algorithms that you can use. Sort of DNS round robin, so literally if you've got 4 servers, every request that comes in, it's going to go server 1, 2, 3, and 4, 1, 2, 3, and 4. Weighted round robin, so if you've got those 4 servers in that pool, you can actually set a priority on a server or a couple of servers that's different to other servers. So those will get preference to begin with before it then moves to the servers with a lower priority. Least connection, so this deals with looking at if a server is, what the status of the server is in terms of concurrent connections to it. So it will move to the next server within the pool that has the least connections. So you're not going to get a round robin effect necessarily. It's just going to go to the least busy server in the pool of servers. Again, you can put a weighting on that or a priority on that type of connection as well. On load balancing algorithm as well. Agent-based adaptive load balancing. So this is where we get the load balancer will use real-time server information from the servers that are behind the, within the load balancing pool to understand what the status is of that server and whether it should be passing traffic to that or not at that point. Chain failover. Notes for this, sorry. So this is a predefined chain of servers that requests are sent to. So they are ordered in a certain order in terms of priority as to what's going to get balanced to in what order. Weighted response time. So this is where we're using the health check information from the server in the pool and waiting to see how quickly our request for server health comes back from the server. So it will balance to a server based on the one that's responding the quickest to a health check. So similar in some ways, I guess, to least connection because it's how busy that server is and how quickly it's able to provide that response. Source IP hash. So this is where the client, there's an algorithm that's used. It takes the client's source and destination IP address and generates a unique hash that then favours a particular server that the traffic is then balanced to.
On the agent-based adaptive load balancing, is that done by like a client installation on the pool servers, or how does it get that information?
So yes, some of the servers there is an agent that you would deploy, the system health monitoring agent that gets deployed onto the actual servers that are in the pool that feeds back that way. Others will use the standard health information that the server is actually initiating a communication to check the server health status on and waiting for the response time.
And do you have to use all these different algorithms? You have to use one consistent across the board, or can you use multiple?
No, so you can, it's a good question. With a virtual service, you can, and we'll see this later on when I do some hands-on, you can define a virtual service either for all ports that you're going to forward to, and then yes, you'd only have the one type of of health monitoring that, or you can define a separate virtual service for specific TCP or UDP ports that you want to forward to. So you could create 4 or 5 services that are listening to the same address, but you have different health monitors based on that traffic, because obviously that port could be providing a different application on that certain port. So you might want to, you don't want to balance everything if you're running both a web server and something else on that server that uses a different port, because if the web server goes down, you don't want to balance your web traffic to it, but the application could still be up with its port and listening on that port. It's quite happy to then accept and process those requests.
And the other thing is any of these like specific to certain load balancers that you brought up earlier? Like are some of these kind of costed out that they're only available on certain?
So I mean, there's some standard ones like round robin, least connection. Those you're going to find on all the flavours of. So yeah, round robin, weighted round robin. These 4 you're going to find on most. This is on a fair few, source IP hash. But the agent-based ones, those are going to differ in terms of what they're called on different flavours of load balancer and how those work. But the Rolls-Royce type, for use that scenario again, the load balancers, the F5s and the net scalers, they're going to have the correctable capabilities. As I say, they have their own scripting engines as well, so you can write your own health monitor processes and agents to get deployed.
So you'd be able to consume our health monitoring endpoint to maybe balance based on jobs currently held on a service?
Yeah, I mean, there's a scripting engine behind that. Yep. Somebody's got that. I haven't got the knowledge to do that. Yep. I'm not a load balancing expert to that degree, to being able to code those things. But somebody that has been on those F5s or those NetScaler courses using things like iRules and the F5, they're going to be able to write those things that can. Yeah, certainly. There are simple ones. When you look on the Kemp, for example, I think on the Kemp you can use a more simple type of rule where you're literally putting an endpoint in an HTTP connection to upstream, so that could work for our health monitors, for example. Any other questions?
Maybe also
Jack.
ask one more. Yeah. Can you do kind of any kind of intelligence to say during certain time periods just use a simplistic robin, but then I'm really getting hammered, you change to a different algorithm or stuff like that. I mean how crazy can you go with the kind of layering these different algorithms?
I guess at the end of the day you pay your money from that hierarchy of the types of load balancer technology. If you're at the lower end of the marketplace, you're not going to get that capability. Again, I know I keep mentioning F5 and NetScaler. Those things at the top end, you've got a lot of capability that you can do from a logic point of view when you get into writing the scripts that actually, the scripts themselves, rather than doing it through the GUI, are creating these virtual services. So that is load balancing algorithms. Health monitoring. So I've talked to some of this already. So across the board, typical health monitors that can be used. There's something as simple and as basic as an ICMP ping. So ping the IP address of the real server. Is it responding to a ping? Which, yeah, that's useful. Not so useful if it's Windows servers and the firewall's on and you're not getting a response from a ping. HTTP, HTTPS, so these are a bit more useful when it comes to, if you are trying to load balance traffic for a website or a web service. That's a basic way of doing that. Something that we would get involved in terms of requiring, from a paper cut point of view, if you have mobility print on the server that is behind the load balancer, is a TCP connection, so 9163, 9164. So that's where you would use that if you're going to split out, as I talked to earlier, different services that we're actually load balancing to on the server. You can do things via telnet. You can create binary data type connections to monitor health as well, so to understand what's going on at an endpoint. The big players, passive health monitor. So this is quite interesting in that this is a bit more advanced, is it can actually, it intercepts the health monitor response, or sorry, it interfaces responses back from the server that you've been balanced to for a request. So this is where the client communication all flows through the network load balancer. So I make a request from a client for a website. Via the network load balancer, I get balanced to server 2. Server 2 then responds, and it gives me 404, web page not found. The load balancer can detect in that communication back that it's not found a web page. It will therefore mark that server now in the pool as offline. It's not serving the web pages that, I mean, that's how I've used a really simple example there, but you can get into that type of logic with these passive health monitors where it's actually looking intelligently at responses coming back. And from that, so that's separate to the health monitor, standard health monitoring, it's actually making a decision, right, remove that server from the pool because it's no longer able to service the clients correctly. Does that make sense? Custom monitors, so as we talked to, you've got the agents that you can deploy and you can write your own custom monitors that can be used for monitoring the server health and the service behind the pool.
What about monitoring services?
So with an agent deployed on the real world servers in the server pool, that can obviously monitor those services on that local box and report back to the load balancer that, you know, the principal is down, for example, on the server.
I guess in the context of paper, you want to be checking your 9163s and things like that for mobility print. You probably want to check your print provider is running, and most likely your print spooler is running as well.
Yeah. But you know, that is going to depend on the load balancer the customer has as to whether that capability is obviously available or not. Any other questions on health monitoring? Okay, so the final part of the jigsaw is, sorry, what I should have covered on that slide, because this is one of Matt's wonderful diagrams, is you'll notice here that we've got 2 servers offline, but the health check is also gone red. So, and this could be important from a paper cut and a printing point of view, is if you're load balancing over a number of servers that you've got within the pool, and we know that we need at least two of those servers for the type of throughput that the client is indicating they're going to be printing. If you lose 2 of those nodes out of 3, as this diagram indicates, you can then actually take the whole virtual service offline, so that you don't end up balancing traffic. Now, what you might be able to do then is to, you know, if you need to use things like the GSLP potentially, that type of level of capability, but you could have additional pools that you could then move traffic to, but you might as well put all the servers in the pool. But it's just interesting that you can, based on the number of servers, you can mark the entire service offline if you lose capability, but obviously you're going to need a way then of either recovering or alerting somebody to the fact that that service is now offline and off air effectively.
When you say the service is offline, do you mean just if we're using it in paper cut terms, do you mean that the paper cut would be offline, or do you mean that it would
print
just
job
push
submission to
everything?
paper cut would work.
Right, okay.
But what you wouldn't be doing is you wouldn't end up with a situation where you're overloading the existing print service. So you would stop, because we're talking about making the print service and the print provider highly available with a load balancer. You would cut off any additional jobs going into those servers, so you wouldn't overload the servers. It would mean, yes, end users would lose print submission capability, but anything that's been printed to the system, they could still release at that point because those servers are not overloaded with incoming print jobs. So, you know, there might be a scenario where that might be useful to certain customers, possibly. Server pool. So the server pool is just that. It's the list of servers, the IP addresses of the servers that make up that pool that we're going to load balance to. And we also define at that level as to whether we're going to use network address translation in terms of that forwarding method. Or whether we're going to use a thing that the likes of Ken and loadbalancer.org refer to as DSR, direct server return. Or in the case of F5, I think they refer to it as MPath, is their equivalent of that. So what DSR is where if you're using Windows print servers, what you would do at a network layer on that Windows print server, or print servers within that pool, is you would add a loopback adapter interface, and then there are 3 registry entries that need to be configured on that server, and these are documented out in the public domain and in the likes of Kemp and loadbalancer.org. There are some great white papers on Microsoft, load balancing Microsoft print servers that detail those 3 registry keys that need to be changed on the Windows servers. What that then means is with DSR, as the name suggests, when a client makes a connection through the load balancer, the server doesn't respond back via the load balancer, it responds directly back to the client. Everybody happy with that? Okay. So, what do we need to do from a paper cut perspective once we have the sysadmin or the network administrator set up the virtual services for us on the network load balancer? So this is straight off of our website, so hopefully everybody is familiar with this diagram in terms of network load balancing. Has everybody seen that? Mm-hmm. Yeah? Okay, good. So what we're talking about here is, as I mentioned earlier, is load balancing secondary print service, so the service we're going to provide on. You know, we're not recommending that we would load balance application service, unless somebody else in the room tells me differently. But that's my understanding is, you know, it's the secondary server layer that we're going to load balance within that pool that I've just talked through. Now, what is really important, and as Damien always puts it, is the cookie cutter type approach. All of these servers need to be defined exactly the same. So if we are using direct server return, because we're going to use standard point and print and make an SMB connection to the queues that are being hosted on those servers, we need to make sure that all 4 servers have the loopback adapter, all 4 servers have the correct registry entries that I mentioned there, and more importantly, all 4 servers are configured with exactly the same print queues on each server. Because otherwise we're going to have issues if we start load balancing to a server where it doesn't have, you know, the appropriate print queues installed on it. Okay, server affinity. So we brief Jack.
Hello. Sorry, this is my thing. I'm going to make an assumption you can't do that with site servers, the same with secondary servers, right? You're going to get data mismatch with secondary servers.
You're right. Yeah, you can't use site servers. Yeah, but you don't get cross-server redirection. So if your site server is talking to one MFD, print provider on it can only, or print provider on that site server can only talk.
So site servers will support cross-server redirection, that will, unless of course there's a WAN outage in which case then we can't get to the other server. So if you had a site server, one in Portland, one in Melbourne, cross-server redirection wouldn't work if you became an island, because we just can't get the job out of there. We will go through a design tomorrow that does have a site server behind a network load balancer as a way of creatively having a device be able to kind of switch between a site server and an application server depending on which one was available at any one point in time. It's a complex design and it's not one that works for all manufacturers, which is why it doesn't exist on our website. Right? When we want to be able to put out good designs that we know are going to work, we need to make sure that they're good designs that are going to work for everyone. So that previous diagram that Neil had, I guess, is our thought-leading version of where load balancers would work with paper cut. When we get the question coming into us, you know, will you work with an F5 load balancer or will you work with with the Netscaler? We go back and say yes, and this is how. You know, people then come in and say, hey, I'm trying to use a load balancer to balance between 2 application servers. They're already too far gone down a wrong implementation for us to, you know, do anything other than say you've gone too far down the path on a wrong implementation and wind it all the way back. So when you get those questions of people saying, do you work with network load balancers, this is the thing that we slide in front of people to at least articulate the right way to get the best value out of that load balancer.
Demi? So without server affinity, hopefully most people are aware of this when it comes to talking about server affinity. If I've printed my print job in via a network load balancer, and that print job has landed on server number 2, and then I go to a multifunction device, I authenticate and instruct the application server to then release my print job. Without server affinity, there is the danger that the incorrect print provider gets requested, gets sent to the wrong, or not the wrong queue, but it gets sent to a queue on another server, which then means we've got to redirect the print job from one of our servers to another server before it then actually gets released on the MFD. So you are going to want to make sure that if you are using a network load balancer, we are using server affinity.
We had that conversation in the room yesterday afternoon as well. It's just one of those meticulous setup steps. So what I actually want to do is I'll record just a 5-minute video on those precise steps you need to make to make the system really sync. It's part of the device and it's part of the virtual queue creation as well. If you get it wrong, and you will try and redirect jobs from one server to another, and one of them dies, you're in a bit of trouble. So I'll share those steps in a video just so everyone can, when they go home and build this, repeat that setup.
Thank you.
Come on, thanks. Okay, any questions on server affinity? Jack?
I didn't see a difference. So.
Yeah. Okay, right, so that's the presentation over with. What I'm going to do now is jump on to 3 network load balancers I've got that have been configured for printing to paper cut, and take you through the steps that need to be configured for each of those different variants. So we will start with the F5 Big IP device. So this is the user interface that you can use to configure the thing.
Sorry, is this just software-based one?
Yeah, sorry, Ross, good question. So this is a virtual F5,
Yeah.
a virtual F5 Big IP device.
Run on appliance sort of thing?
Yeah, exactly. So this particular version I think is running in vSphere, that it can be deployed, as I mentioned, as an instance in a cloud environment, which is what you're going to use when you get to the hands-on.
Do they do like a freebie version of that?
They do a 90-day trial.
Yeah, I think that's what we played with in the past, yeah.
Yeah. Sorry, my laptop has switched wireless networks again. So this interface is going to look if I started to click on these, it would look a lot busier than this in terms of configuration options. For load balancing, the only area that we're interested in configuration is this area here, the local traffic tab. So if I click on that, which F5 referred to as LTM, Local Traffic Management Manager, the first thing that we would do is we would define the servers, the real world servers, or the nodes in this list here. So I've got 2 print servers defined here, which I'm literally, when you create these, click on create, you literally just give it the IP address or the fully qualified domain name of the server. You can at this level assign health monitors. We're going to do that at the pool level rather than on the individual nodes. So the pool level is what ties those real world servers together and will apply our health monitor capability onto. So I'll be back out of this. So I've then got two pools defined, one for balancing traffic for a web server, and one for balancing traffic for print, IPP print. Click on web server. I can see here I'm using a simple health monitor, an HTTP health monitor that is defined, and the members of this pool are those two print servers, and I am simply doing a health check on TCP port 80. It's on my website to make sure that the IIS is running on those back-end web servers and it's listening on port 80. We then go up to virtual services. I've then created a couple of virtual services, again because I'm going to balance web traffic for a simple website, but I'm also going to do that IPP print connection balancing as well. So I've defined a virtual service for each. I go into the web server one first. So the simple settings that I've defined here is that it's a standard type virtual service. I'm going to accept traffic from anywhere. That's defined with this attribute here. The destination address remarks, this is the virtual IP address that I'm going to use. So that is defined. The service port, so what I'm actually going to forward, which is port 80 requests. When they come in, their port 80 requests will get forwarded.
Can they be put for free?
Yep.
Cool.
Yep, certainly. There you go, there's a list of predefined ports. And then on the F5, the other thing that I need to configure is source address translation to automap for this to work. And then it's not visible here now because the service has been created, but down here there's an additional section which is where you then select the pool of servers that you want to balance those requests to. And I can actually see that under the resources tab here. So the default pool is that web server pool that I've defined down here, which holds the link to all the servers. So configuring load balancing of a web server really is that simple, even on an F5, in terms of getting this up and running. What I should have mentioned, in the pool, I've defined the load balancing algorithm that I'm going to use. So if I just go in and generally create a new one, you'll see that here, load balancing method. So I would define here what I'm going to use, round robin, least connection, etc.
Which one would you generally recommend, round robin?
From the tickets I've seen from real world customers, they tend to favour least connection. That's what they seem to be asking for, calls that have been involved in. And that might be more historical because of what they're used to configuring, but that's what tends to be the request.
From our point of view, I wouldn't normally get that deep in with a customer.
We're not expecting.
I don't want to tell them what to do. That's up to them when it goes wrong.
Yeah, but it's just if somebody starts throwing the words virtual service,
Yeah, sure.
virtual IP, system health monitoring, the idea is to give you enough to be able to say, well, right, our virtual service, we need to be forwarding ports, as Damien mentioned there, standard printed ports, so 9100 or 515, or in the case of this scenario, IPP 631. That's what we're going to need our virtual service to find as. But you're right, it's down to their admins, and if they've made the investment in something like an F5,
They hopefully know what they're doing.
hopefully they're going to have trained somebody up to be able to configure the thing. You would hope.
And the good thing is, with PaperCut sitting on top of a lot of all of this, if you took PaperCut away, what a horrible world that would be. But what would they do if they wanted to do it without PaperCut involved? Spreading print jobs around and things like that, and keeping servers active. So you can just go back to all of that. Pretend PaperCut, you don't have PaperCut. What are you going to do to,
I
spread the load?
guess the biggest difference you might walk into is if a customer has traditionally been using a network load balancer to balance web traffic.
Sure.
Yeah, then they might not be used to the configuration of something on an F5 like mPath for that direct server return capability. That's possibly where the knowledge gap could be in an end customer. But hey, if it's an F5 or a NetScaler, they've got access to the resources that those companies provide and the experts that
Yeah.
can point them in the right direction.
Yeah, I suppose it's just knowing which parts actually affect paper cut in our eyes. So is there anything that's got to be done or is definitely a big no-no? And direct server return is one of them, but there's
It definitely is if
it's
you're
whatever
using
else
point of
there
print.
is in there that's
That's it. It's very much a case of knowing the paper cut world as best you can, and then even if you don't have the answer with the customer, if they've got the expert within the organisation, you're going to be able to work out the answer together. So I'm with you. I've never found myself in a conversation where I've had to talk to people about their choice for balancing algorithm, but we do find ourselves in conversations with people wanting to talk about, well, what do I need to test to make sure one of these things drops out of the pool of available servers when things go wrong, and you need to know your ports, you need to know the services that are going to be used as well, and then you can work out that answer together. This could be part of, do you have the monitor on there, as Neil was saying? If you don't have the monitor on there, you're going to need to do TCP checks, you're going to need to test ports. If you've got the monitor on there, you'll be able to check services. So it's part of that conversation. You know the paper cut system, we're becoming experts in that. We aren't experts in load balancers, but if you've got someone who is an expert in that, together you'll be able to come up with the right answer.
People are just nervous normally, or they're used to other solutions that are maybe a little bit trickier to get up and running.
Nervous and trickier, and also are looking to move responsibility elsewhere as well. So as you said, if someone asks you the question, you need to help them find their answer, but it needs to be their answer. Otherwise, you're going to be on the hook when things don't go wrong.
I'm not
so I
that
think
far
we're all
technical
experts
sport.
in not being pinned to the wall in this room, but especially with this, I mean, all of this exists before paper cut. Right, this is effectively network infrastructure that we're looking at here. It's fun to look at, and it's really important to understand how it works with paper cut. But all of this exists before paper cut, so the less your fingerprint exists on this stuff.
Yeah.
Okay, so I've configured the virtual service on the F5 to 10.00.13. So if I just make a quick connection. So I've already made a connection on this workstation. To that virtual queue. So if I go ahead and put a couple of print jobs in. We should see, but as we saw yesterday when we looked at load balancing, those jobs have now been balanced across the two servers and end up within paper cut. So that's the F5 from a chem point of view. So this is actually the load balancer that we were using in yesterday's session.
Again, this is software again, yeah.
This free Loadmaster is, yeah, but again they do make hardware appliances. So if I go in here, I mentioned global solutions load balancing. So even on Kemp, you've got that capability here. You can configure some of that. And you can see here I've got multiple virtual services defined. So the first three are all for paper cut. So obviously we're load balancing, in this case, all ports to the servers and the server port I have defined. This. We can then see here, similarly, within the standard options, we've got the scheduling method, which is that algorithm that's being used to load balance, which we've got set to round robin. And then the real world servers down here. You'll see we've got the IP addresses of the servers, and we use that for the method NAT here in this case because we use an IPP. So that's how you configure the IPP. Similarly for DNS, so for mobility print, we're forwarding TCP and UDP 53 if we're using DNS SD. And then the service I've got down the bottom here, which is disabled at the moment, this is what you would set up if you were going to use traditional point and print and make an SMB type connection through to a print queue. So the forwarding method does change to that direct return that I mentioned earlier. The other settings are similar in terms of forwarding method, etc.
Is the difference between layer 4 and layer 7?
So the difference between, obviously layer, in terms of the OSI model, the layer 7 is the application layer. Load balancers will work from, I think it's layer 4 upwards, but they don't go down to the lower levels. So if you're, layer 4, if you're wanting to forward TCP and specific UDP, but not application type ports, that's where you use a layer 4 type virtual service. If you're just looking to forward HTTP, HTTPS, those defined ports, you use a layer 7.
So therefore IPP accounts as layer 7 because it's HTTP.
Exactly. Yeah. Any questions on Kemp? So again, hopefully that's shown how simple. I mean, who set a Kemp up in the room?
Commercial use?
That is a good question.
There
Free
is,
load balance. But I
there
think
is,
a
there is
free-
a free version
Yeah.
that is limited in what you can do with it.
It's, I think
it's-
throughput's limited, isn't it? And GSLB, you can only define 2 GSLB.
Yeah.
Some of them.
Yeah. But if you want it to the better one, you go for the pink one.
Okay, so that's Kemp. I've still got some here. What I then have is an Nginx setup. So this is the software load balancer.
Just type sudo a lot.
Yeah.
I can write sudo, the rest of it I can't write.
Okay, let me just bring up the text, but I won't stay in here long, I
Pseudo
promise.
English.
Okay, so this is on an Nginx load balancer. This is the configuration file that controls the load balancing from its point of view. So there are similarities in this text file. You can see that the upstream servers is that's your pool of servers that you're going to load balance to. From a layer 7 point of view here, we've got port 80 defined. And then upstream, which is used typically for, I should put it down there, typically used for those TCP and UDP type connections that aren't defined services, so we're doing it at a layer 4 level. Are defined here, so you define again the IP address of the server. You actually define here the type of load balancing method that you want to use. So in this case, we're using least connection. The reason I've got that in there is because I think this file is configured, yeah, it is, with other ports, so for mobility, print, etc. But yeah, so it's a basic text file configuration using that type of load balancer. Okay. That's it in terms of me showing you load balancers. Are there any questions on what I've covered?
So when you've got a load balancer, what mechanisms can you use to map the queue to the client then? Is it only IPP or can you use something else?
No, so if you are using direct server return,
Yeah.
that will allow you to make a standard, SMB type connection to a print queue
Okay.
on a server behind. You're obviously going to make that connection, and once you've made that connection, if it's holding that connection open, if I'm balanced for server 1, server
Yeah.
1's online, and I start printing print jobs, all my print jobs are going to end up on server 1. Similarly, if you were to connect and you get to 2, all your jobs will end up on 2. So that's
How did you add the queue in your example on the client?
the
That's
queue
not-
here,
I
is,
don't
the
understand
queue on the
that.
client is an
That's a
IPP
bit-
queue because
what
my
was it?
service is defined as.
So how about the driver and all that sort of stuff when you're going through a load balancer, how do you control that?
So an IPP queue, as you know, when you connect to an IPP queue, you're
Yeah.
going to have to.
How will you push that out to an organisation?
The
That's the question, isn't it? How would you do it?
The reason that IPP has been chosen for this example is it then shows that balancing, which is something we want to get across to the room.
Yeah.
Is the balancing between the two servers. That
But
in
in reality,
reality, most
corporates,
customers
how would they do it?
You'd
Well,
use SMB.
you'd use SMB.
SMB, yeah?
Yeah.
Okay.
So you would define a layer 7 virtual service,
Yeah.
and use direct server return
Yeah.
with your Windows print service behind.
Mhm.
Windows print service behind, you'd have to add the loopback adapter, add these 3 registry entries onto that server.
Yeah.
Same on the servers in the pool,
Yeah.
and then as the, you can then map a queue coming through the load balancer. So you go / load balancer or virtual service name
Yeah.
/ find me,
Yeah.
and it would then route that.
It'll route that
connection to
straight
the
through,
service.
and then just like a normal queuing, yeah?
Yeah.
That's what people use it really, isn't it?
It is,
Yeah.
in reality, yeah.
Okay.
Was there a steep learning curve, or were you born knowing about load balancers?
It involved a large German bank, and
A load
3
of
years
trouble.
of my life and me ripping my hair out.
Welcome back again.
That's the reality of it. And then, some healthcare trusts as well that
Yeah.
then started to use that particular.
I've had 3 or 4 customers implement this. Obviously, we don't have the experience of implementing it ourselves. But as I said to you yesterday, people keep asking, how do I set it up? And it's people with F5 who don't know how to set it up. But to spend that much money on a unit,
So that's an interesting point then. So are that's all on premise presumably? Is
yeah,
it?
yeah.
It's not as though it's the cloud.
I've had at least 3 customers contact us to say, how do I do it? I've got an F5, how do I set it up?
Don't worry, I deflected the Kent ones and did those before you, so.
Yeah, but we don't want to get involved. It's a can of worms as well.
Yeah, I mean, we don't want to be telling them what they need to configure step by
Exactly,
step.
yeah.
do we? That's because we're not load balancer experts.
Yeah.
But there are a defined set of ports that you need to be able to forward from the load balancer
Yeah.
stance, and we're aware that general best practice from load balancer experts is that if you are using Windows print servers, you would be using direct server return.
So have we got any article written on this or not? Or can we get something written? A fact sheet or something? That would be helpful, I think. We could just then give that to the customer.
Yeah, but it's that agnosticity. I don't even know if that's a word, but
Just a one
It's a
page.
good enough word.
Thank you. I like that word. Yeah.
Just to-
Can't say it, but I like the word.
There are kemploadmaster.org. Their documentation, they have specific white papers that detail everything that needs to be done from a cookie cutter point of view on the servers behind the load balance. From a Windows printing point of view, obviously print providers sitting on top of that infrastructure. So
If it helps, we'll find that way to find that right balance, which is giving a bit of advice that allows the customer to make the right decision. And if it helps to do that in a knowledge base article where we talk about what we know from paper cutters, we know we need to have the right IP of the print job for all of these reasons, and we can refer people to documentation on an external website that says, and here's how you go about setting that up, so that we set up the reason why you need to do this thing, and then take them to somebody else's documentation that allows them to do that.
That would help.
Yeah. And that might be the right little
And
for us as well.
Yeah, just point in the right
Yeah.
direction.
Yeah.
Maybe putting in something like all of my sort of here's a basic thing to look for if you're trying to troubleshoot it,
Yeah.
because somebody's saying all of my jobs are going to this server even though it's going through a load balancer. Just to say, well, okay, so you've got the health monitoring, you've got the whether you've got least connection, the weighted round robin if you've got any of those, then these
I think
are
that's too much.
these are a
It's
couple of
a
things to
high
look
level.
for.
This is what you need to. This is what you need. It's high level. You don't want to go into too much detail.
yeah, I think they probably need to make the decision on which load balance and how.
You need better customers, basically.
What can we do then?
Okay, right, your turn. So, everybody in the room has access to the back of this document I'm just handing out on the last page.
Okay.
There is a grid which has got server names and usernames for everybody except Ross, I'm afraid, so I was expecting you to be next. You've not got a laptop anyway, have you?
No. I didn't come here to do any work.
You look over my shoulder.
Yeah, man, I'll welcome you.
So all you're going to need from your machine is a remote desktop
Password is wrong.
connection and to be
Good start,
connected
isn't
to
Oh,
the
yeah.
TechFest wireless access point. And then those IP addresses there you should hopefully
Yeah, that's
mine
fine.
is saying like that.
Yeah.
So details and your username